If n is equals to 5 factorial, 8 factorial, 9 factorial multiplied, then find the number of factors of n which are square integers. So let's look at the keyword factors, square integer, and now my n is a very complex mathematical term written in terms of factorial. So let's see what is a square integer. Square integer simply means integer that is the square of an integer. In other words, you can just say it is the product of some integer with itself. I can say 4 is a square integer, 9 is a square integer, 16 is a square integer, 25 is a square integer, as well as 1. Why? I can do 1 times by itself, 2 times by itself, 3 times by itself. See, when the integer is multiplied by itself, then these numbers are known as the square numbers, and the list goes on, and I'm sure you already know this. Now let's see what is a factor. How do you find a factor? I'm going to use 5 factorial, and I want you to express this as prime factorization. How will you do it? First, you have to find out, at a lower level, you will express this as 5 times 4 times 3 times 2 times by 1, and you already know this is 120. Usually, your teacher taught you to divide using the easiest prime number, which is 2. Then you will get a 60. Keep going, repeat the same procedure until there is no divisible possible, and you will write the prime factorization of 5 factorial as 2 cube times by 3 times by 5. Okay, now if I ask you to tell me what is the total number of factors for 5 factorial itself. See? Of course, it is going to be a lot. How do you find that without listing everything? It's kind of simple. You take your prime factorization. You look at the power here. I have a 3, and then this is a 1. Here also it is a 1. Now the formula is going to work this way. You take the power and then you just plus 1 to it. The first one is 3 plus by 1. Then the next one I'm having a 1 here. So what is 1 plus 1? You're going to write it as a 2. You repeat the process until you complete the prime factorization for 5 factorial. And that is going to give me 16 of those. You can take a moment and then you can try to list it on your own. And when you do that, you're going to get like 1, 2, 3, 4, 5, 6, 8, 10, 12, 15, 20, 24, 30, 40, 60, 120. So these are all the factors for 120. Let's count. How do I exactly have 16 over here? You can give a count. 1, 2, 3, 4, 5, 6, 7, 14, 15, 16. Okay? That's how you do it. But are we answering the question? No. I want to find the number of factors of n, where the number of factors has to be a square integer. So again, I want you to do for the smaller one. You take this 120. Tell me, identify the square integers. It's 1, 4. That's all. That's all, right? So how do I do that? It's quite easy. What you have to do, you have to look for the even power of the exponent. Okay, to get the perfect square, the power of the exponent in the prime factorization must be even. So I look at this. I'm having 2 power 3, right? So you try to express. It can be 2 power 0, 2 power 1, 2 power 2, 2 power 3. Which of this power is actually even? It's this one and this one. Let's try with 3 power 1. I have 3 power 0, 3 power 1. So there is only 1 here. 1, see, the 1 here, it's not even. So you cannot include that. Similarly, here you're going to get 5 power 0, 5 power 1. So I'm only selecting this. 5 power 0, 5 power 1, 5 power 2, 5 power 3, 5 power 4, 5 power 5, 5 power 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71, 72, 73, 74, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96, 97, 98, 99, 100, 101, 102, 103, 104, 105, And then what you do? You multiply in order to get the answer. So in this row, I have 2. Here I am having 1, and the last one I am having another 1. So total is just 2, and that 2 is this one. We apply the same concept in order to do for a bigger number. So what is the first step? You have to express this n in terms of prime factorization form. So how do you do that? We maintain the 5 factorial. The 8 factorial can be written as 8 times 7 times 6 times by 5 factorial. For the 9 factorial, I'm sure you can do this already. Now, can you see you have 5 factorial 3 times over here? And take a look at your 8. Your 8 is repeated twice, your 7 is repeated twice, and 6 also repeated twice. So I can write this as 9, 8 squared, 7 squared, 6 squared, 5 factorial cube. Since I already know how to express my 5 factorial in terms of prime factorization, that will make my life easy. How can we express 9? 3 squared. How about the 8? 2 power 3 squared. 7 squared. 3 times by 2 squared. So this is what I'm doing for the 6 power 2. The 5 factorial, it's here. Let's substitute and continue. Use your index law and simplify as much as you can. At this point, we can simplify all of these, and I think you can see for the 3 as well. You add up the power. So for the 3, I'm going to get 7. For the 2, I will get 17. And for the 5 is a 3, for the 7 it is a 2. I already got the prime factorization. Now I'm just going to apply this particular concept and solve my problem. What I just need the even powers. Instead of writing vertically, I'm going to shorten it. Just list out all the even and you count it. Do the same with the next one. So how many do you have here? I think you have 9, and here you have 4, here you have 2, here you have 2. You take it and then you multiply. You will get 140.